All right, so listen up. We just finished another like combo lesson, and that should really be the only one. The rest should be individual lessons. And the reason why we combine them is because some points are really easy that I could just like summarize for you in a few sentences. But also like you actually engaging in certain situations and certain materials helps you remember them more on the test. So that is why we do that. Partners and now here's what we were supposed to be able to accomplish. So let's see. Can you look for patterns in two-way tables and relative frequency tables to see if there is a possible association between two variables? So can you look at data and see, does that data maybe have a relationship? That's what association means. Yes, no? Okay. Can you describe rate of change, which is another word for slope? Rate of change and y-intercept for a linear model. We didn't really get to that part, but when we did create the linear model, all right, that's the equation we got. What is the slope? What does the slope mean in the situation? The 0.19. And sorry, what? The 0.19 is the slope. It is the rate of change. What is changing? For this experiment thing we collected, the data, what changed each time? Maybe if I pull up the table, you remember. The weight changed each time. And it changed every time one orange was added. So the rate of change being 0.19 means that with every additional orange, the weight increased by about 0.19. Does that make sense? So that's a few questions on your test. What does the 0.19 mean? You would say something to that effect. With each additional orange, the weight increased by 0.19. All right, now for the y-intercept. So let's look at our graph for that because we don't have our y-intercept on the table. But we have it on our graph that we made. Our y-intercept was about 0.6. So what does that mean in this situation? The weight is 0.6 when a really great test question. Giving you a random situation. Our random situation today was oranges being added to a box and us looking at the weight each time. So what is the y-intercept of 0.6 representing about that situation? Well, one orange weighed a little bit more than that. To try again, how much the box weighs when there's 0 oranges in it. Make sense? Because that's when there's no orange in it. There's still weight because the box has some weight, so the box must be about 0.6. That's the interpreting slope and y-intercept. So can you do that on a test with whatever random situation they need? Okay, if not, that's a little taste. We'll do some more tomorrow. Now also drawing a linear model that fits the data well and using the linear model to estimate values you want to find. We even spent a lesson in math lab doing that, so hopefully that was easy today when it came up. But using it to estimate values that you want to find is like what this part was. We didn't actually find the answer, but you could. When there's 11 oranges, you just have to times it by 0.19 add the weight of the box, 0.6, and that'll give you the estimate. Could the actual answer probably be different? Yeah, it was just an estimate. But based on our linear model, it'll probably be close to whatever that calculates to. All right, so that was all the rules of today. Now, what you will be doing in here is getting your practices done. They are separate again, but it was for today's lesson. 5 questions each, try to get 80% or higher on both. Ask questions as you go. If you are struggling, like you should never have to spend more than maybe like 5 minutes on the topic. Especially when I'm right here. All right, any questions right now? All right, so that's the points for today, getting 80% or higher on both. Next semester, I'm thinking about changing up like the grade categories and doing like the daily task as assessments, you getting 80% or higher on the practice. And then all the other stuff as like classwork and projects. So just saying, some of you have been really slacking on this, maybe because it's classwork this semester. Next semester, I'm thinking about changing. So do this 80% or higher, or whatever else you need to get done, like your math lib, resubmitting, things like that. From lesson 3, which value would best fit in the missing cell to suggest there is no evidence of association between the variables? So association, also known as correlation or relationships, that would be like as one variable increases, so does the other, and vice versa. Like if one decreases, maybe the other one decreases, something like that. So looking at this, when we are comparing different types of watches that display dates or not, if we want to show that there's no relationship between them, let's just kind of like plug in numbers and see if we do have options. So if I plug in a 9, does that have a relationship? Okay, so maybe, so it looks like that would show that the analog watches, I don't really know, honestly, like, it's kind of a weird question. Because those variables, I don't know that they're related or not in the real world. I don't think that they would be, it would just be their choice to either put the date or not. So. Let's see. Now, I don't really know, but compared to all these other numbers, this one is like half of that. This one also looks like half of that. So there is kind of a pattern. So I'm thinking that it's not 9 because that kind of is following a pattern. So maybe don't pick that one. We'll see what the real answer is in a second. 18. That to me might just show not much else. Like then it's showing that this is less than both of these in both situations. So then maybe that's not showing a relationship. We want one that shows no relationship. So like that could be a relationship of like these just always have no dates. There's always less than those that have dates. Question? Yes. If I put a 27 there, maybe I think it's this one, but we'll see. There's probably one in these two. Because this one decreases from left to right, and this one is increasing from left to right. So, but I do think that's showing some sort of association, saying that like digital watches mostly have the date, and so the analog watches mostly don't. So, or I guess even amount of both. If I put a 54 there, let's kind of compare that. Now it's showing as this one's decreasing. This one is increasing, which kind of would make sense compared to like ones that display the date and ones that don't. So based off of that, I would say that the answer is 27. Let's see if that's right. If not, I might just delete it because I don't think that's like a really cool question. I don't like this question. I might just delete it. Yeah, I agree. But let me see, let me look at the key, make sure that there's not, maybe, I don't know. Sometimes there's errors when they make this, so let me check. Like yesterday, we found that one of the questions on the homework was missing some information that you would need to actually solve it. But you guys didn't catch that. Someone else did. Yeah, I don't like this question. So I'm gonna delete it. I don't get it. All right. Any other questions? Usually a good way to tell about associations is when one increases, the other one doesn't, or when one increases, the other one decreases, things like that. Brady? What'd you say? On lesson 3? Okay. So is it the one about an automobile? All right. So an automobile dealership keeps track of the number of cars and trucks they have for sale, as well as whether they are new or used. Based on the data, does there appear to be association between the type of automobile and whether it is new or used? Complete the following to explain why or why not. So the blank appear to be an association. Do you guys think that there's an association? So it looks like when there's a car, they prefer, majority speaking, new cars. When it's trucks, they also prefer new trucks. This might be where you make a relative frequency table to compare like in total. So that's probably what you'll have to do. And we're wanting to know whether it is new or used. So out of the total cars bought, what's 812 plus 422? That total I got 1,234. For the total trucks bought, that would be 280. My pen, of course, is like the library now. 284. So out of the people that bought cars, what percent bought them new? So that would be you taking the value here. And it would be 812 divided by however many total cars were bought, which was 1,234. Times it by 100%, you get about 66%. And then here you could either do 100 minus 66 to get the other percent. Yeah. Or do the 422 divided by 1234. And that's about 34%. Here. Now for the trucks, that would be 233 out of 284 that bought them new. So that's 82%. So maybe that's what we were supposed to do in number one, is make a relative frequency table so that we could see the answer better. But I already deleted it. So. All right, so then 51 divided by 284 is about 18%. So do you guys think that there is an association about the type of automobile that's bought, whether it's a car or truck, and whether they like to buy a new or used? Do you think that there's a relationship? Based on those percentages now?
Yeah.
I think so. I would say there does appear to be an association. About blank of the cars at this dealership are new. What percent of the dealership cars are new? 66, remember we calculated it, right? 812 divided by 1234. And then, but blank of the trucks at this dealership are new. Okay, good. The much greater percentage of trucks that are new does or does not appear to suggest a relationship. Does. Now let me make sure that matches up. So that's how you figure it out. You try the relative frequency table like we did in the lesson, and then see if that's proving a relationship or not. Since they have so many new trucks and very little used ones, that probably does suggest people prefer used trucks. So I think it marked one of them wrong. So let me fix it because I think we are right. Yeah, we are right. So let me fix that. Okay, yeah, I'm fixing it right now because it should be about 66%. No one has one more question to ask? Very chatty today. No one has a question that they still need answered. Okay, well, I fixed it. So there you go. It'll rescore within a few hours if you already submitted it. But goal should be 80% or higher. If you end up needing more attempts, do email me, let me know, include the lesson title, so that way I can reset the right one. Any other questions? Okay then.